I realize this is not a Star Wars theme song, but A, I've already done Star Wars, and B, who doesn't love good detective shows clear back from 1960 is what Wikipedia says. All right, bias versus variability. For this, I want you to pretend that you're a stormtrooper and you have a blaster gun and you're aiming at a target, and there's 4 different guns you can choose from, and here's how they shoot. With gun A at target A, now remember, each time you pull the trigger, it fires like 30 bullets. So there's how it hit for A. Let's try target B. Now, I realize what you're thinking is, I need to improve my aim, but the gun is the type that every time you pull the trigger, it randomly deviates, and so you can't plan for it and you can't correct it. For gun C, and last but not least, we have gun D. So every one of these guns has a different combination of bias and variability, and every science talks about these. In business, they call this expected payout and risk. In guns, they call it the precision and the accuracy. Here's how we are going to define it, though. Notice some of these are centered over what you are aiming at. These 2 are centered over the target. That means they have low bias. Meanwhile, the other ones that are not on target, these would have high bias. Notice also, sometimes the bullets clump together very close. Other times, there's a lot of spread here. We call that variability. So these guys have low variability, whereas these guys have high variability. Now, if you're Darth Vader, which type of gun are you going to give your stormtroopers? You're going to give them this one. They're going to hit on target, and they're going to do it consistently. However, if you're an action movie director, which gun do you give the bad guys? Right over there, hitting all over the place, of course, never actually hitting the good guy. Here's the gun that James Bond uses. There's the gun that everybody else in the James Bond movie uses. The point is that you can see easily this one is the best. We don't like bias. We don't like variability. So we like something that is low on both. Here would be the worst because it has both bias and variability. Between these 2, which would you vote for? In class, I'll actually ask students to raise their hand and they'll be split. Someone will say, at least my bullets are all consistent. This one will say, well, at least I was over the target. There's argument here. In psychology, they would talk about, are you risk averse? I know what I'm getting, even if it's not as good as it could be. Or are you a risk taker? I'm going to center it over what I want, even though there's a lot of variability in what could happen. For this class, these terms are a big deal because the target represents something we want to know, some parameter that we're after. Like, I want to know the true proportion of students at UW who are vegetarian. And so each of these different types of guns is a different type of survey. Let's imagine that I assign everyone in the class, all 300 students. I want you to go out and do a survey like this. Here would be an example of where everyone in the class is getting about the same answer, and the answer that they're getting is about the right answer. This would happen if I made you sample a huge amount of people. Go out and survey 250 people. That's kind of a lot. And just ask, are you a vegetarian? Straightforward, simple question. Now, this would be an example of where everyone is getting about the same answer, but they're all getting the wrong answer. This happens if we get a large sample size, but with a biased question. Are you a meat-destroying, cruel carnivore? Well, some students are going to be like, yeah, totally me. Some students will be like, no, I guess I'm not. Well, you're getting biased results. Because your sample size is so large, everyone in the class is going to be getting biased results about the same way, because the percentage of people who view this as offensive or who view this as really cool, you should be getting the same percentage with such a large sample size, but you're getting biased results. Over here, we're getting that people are around the correct answer, but they're getting a lot of variability in their answers. For example, this happens if our question is straightforward, are you vegetarian? But our sample size is really small. If you only survey 25 students, well, sometimes you might survey a lot who are vegetarian or no one who is vegetarian. And so you're going to get a lot of variety in what students come back and say. Here's my percentage, everybody's getting a different percentage. If I clump everyone in the class together, yeah, it'll be centered over the right thing. but because each person did a small sample size, there's a lot of variety in what they're answering. The worst case scenario would be a small sample size, and are you a tree-hugging, wussy, non-meat eater? Well, gee, you ask a question that biased, you're going to come back with everybody getting bizarre answers, and none of them are close to the real answer. And so you've totally messed up your ability to actually get any accuracy or use here. So the next time you're watching an action movie, I want you to say to yourself, wow, our hero has a huge sample size, totally unbiased questions. And then every now and then you'll see a bad guy and you'll be like, yeah, tiny sample size and doesn't know how to ask the question. I know exactly what terms to use for this: bias and variability.